Hey, so for this video, we have the big screen. Big screen means math time. Yay! So, we're gonna do the first attack time calculation here. So I kind of took a piece of the information that was given by the problem. So tack time is, as I said, the pace of the customer, the pace of the demand. And we have that information about the average demand is 3,200 per week. And here we have the 8 shifts, 8 hour per shift, and 1 shift per day with the 30 minutes lunch breaks. So let's write that down. Tack time is going to be equal to daily availability. So we have 8 hours per day, right? Minus 1 because it's the 2 times 30. Well, then I put it then and 30 minutes per day. So I can say 30 times 60. Then we're calculating everything in minutes minus 60 because that's the 2 times 30, and all of that divided by 3,200 because that's our weekly demand, right? And I forgot here is just to multiply all that by 5 because it's 5 days in a week, right? 8 hours is just 1 day, okay? And I'm actually going to take all that because these now are in minutes per week, and I'm taking all that and I'm going to multiply that by 60 to make it seconds, okay? And that gives me 39.4 seconds per part. Okay, oops, we got out of the drawing. Okay, now it's good. 39.4 seconds per part, okay? And that's my tack time, so let's put here B, okay? Let's go to our next one. And now we need to calculate lead time, right? So that's C. So the lead time is mostly accounting for the raw material, right? So how much raw material I have is going to be 5 days of inventory, and I know that because it's already given to me 5 days. But then I have to look at the material between press and pierce. And there it's in quantity, right? See, there's a quantity. I have 1,000 of left side and 1,250 of S product. So L product and S product. So to calculate, to make it in time, I need to divide that by the daily demand. So that'll be the 2,250 divided by 640, which is the daily demand. How do I get the daily demand? So that's the weekly demand divided by 5. It's the daily demand. Okay, so weekly demand divided by daily demand. I'm out? No, I'm good. Daily demand. Okay? And that I get my weekly demand. So that's my, from the weekly demand, I get my daily demand. Okay? Oh, sorry. Let's do it again. So the daily demand, oops, is going to be equal to the weekly demand divided by 5, right? Because I have 5 days in a week. Okay, so yeah, I forgot about that. So here it gives me the 3.5 days, and then I'm gonna go to the next between pierce and grind. I have 1,050 plus 2,300, so 3,350. 1050 divided by 640 and that's equals to 5.2 days. And then the last one between finish and shipping. I'm not good today. Between pierce and grind, so grind and shipping, right? So that'll be 500 plus 975, so 1475 divided by 640. That's going to be 2.3 days. And I just need to add this up. So 5 plus 3.5 plus 5.2 plus 2.3 equals to 16 days. Okay, and that's my total production lead time. Total. Okay, then I can go to the next one. It'll be total processing time. So I'm going to do another piece of paper here because it was getting too confused. So that's D, and processing time is just the sum of the cycle times, right? So I have the press cycle time of 12 seconds. So processing time equals to 12 plus 34 plus 35, and I can do that because all of my process only have one. I'm only doing one at a time, right? So imagine that processing time will be the time that you're adding value one after the other. Each time I'm adding value to one product at a time, and that's just one step, right? So I have one product and then leave. So that's an easy way to calculate that. And that is 81 seconds, right? 81 seconds. Okay. So next video I'm doing capacity because this is becoming too big. So capacity will be our next video.